And there's just one more thing that we have to go over. These plus or minuses. Just think about whether the situation should make the observed frequency, f prime, go up or down. These problems are going to be so much easier when you remember these rules. Anytime the source and the observer move apart, the observed frequency will decrease because the wavelength is increasing. And anytime the source and the observer move closer together, the observed frequency will increase because the waves are getting compressed. If the observed frequency should be higher, then you pick the signs that make the fraction larger. And the fraction is larger when the numerator is greater than the denominator. Let's quickly go over why this works. Let's say there's a sound emitted from a siren of 500 Hz, and you're told that the source and the observer are moving closer together. Then you know that the observed frequency will be higher than the actual frequency, so the numerator has to be greater than the denominator. In this example, our numerator 3 is bigger than 2, which makes our observed frequency equal to 750 Hz, which is what we expect because we're told that our two objects are moving closer together, so the observed frequency is higher. Let's see what happens when our numerator is smaller than the denominator. In this example, 2 over 3. This will make the observed frequency sound lower, roughly 333 Hz. So when our numerator is greater than our denominator, we will have a higher observed frequency. And when our numerator is smaller than our denominator, we'll have a lower observed frequency. Back to these rules. When they move farther apart, the numerator will be lower. But when they move closer together, the numerator will be higher.